Okay, question 6 asks for the derivative of some functions. Some of these questions involve a g of x and an h of x that are not specified, and the answer will thus involve h primes and g primes. Okay, first problem. The function is f of x is equal to 3. We're asked for the derivative. Well, the derivative of 3 is 0. Derivatives are rates of change. Constants, by definition, don't change. Otherwise, they wouldn't be constant. Constants don't change. So, must have a rate of change of 0. Thus, a derivative of 0. It's enough just to say equals 0. I want to put an explanation for that because it's often just treated as a rule to memorize and nobody knows why. But that's and the definition of the derivative in terms of the difference quotient. That's another reason you could come up with this. Part B, f of x is equal to e cubed. Now you may have started writing 3e squared, thinking that e is the same thing as x, and it's not. E is a number. E is constant. So e cubed is also constant. Constants don't change. The rates of change are 0. So the derivative of e cubed is 0. This is just the derivative of a constant. Okay, next problem. I'm going to use a trick for this. When you see a quotient, when you see a fraction in derivatives, you probably are immediately going to quotient rule. And there's nothing incorrect about doing that. You're just making more work for yourself. Less work is to use an exponent rule, that 3 divided by x is the same thing as 3x to the power of negative 1, and then take the derivative using the power rule. So the old power comes down, and the new power is the old power subtract 1. So minus 1 subtract 1 is negative 2. We get negative 3x to the power of negative 2. And then use our exponent laws to simplify 3 over x, or negative 3 over x squared. For the next one, the x is on top and it's being divided by 3. I'm going to rewrite this as well. Dividing something by 3 is the same as multiplying it by a third. And x without a power on it is the same thing as x to the power of 1. Well, I should write down power rule here. Okay, now we're going to take the derivative for question D. We're going to use the power rule. The 1 will come down. We'll have x raised to the power of 1 minus 1, so x raised to the power of 0. One over 3 times 1 equals 1 over 3. The quotient rule after simplifying would give you the same thing, but what a waste. Okay, next problem. F of x is equal to ln 3. This might not be review. I don't know. But in Math 0110, in the version of introductory calculus that we teach at Western and at King's and here on at Brescia, we have a section on derivatives of exponential functions and log functions. And in that section, which I think is supposed to be mirrored in high school calculus, it used to be, I don't know if it still is, you also learn how to take derivatives of exponentials and logs. Now, however, that said, this ln of 3, this is a constant. There's no x in there. This is a trick question. So the fact that this is a constant means that f prime of x is equal to 0. Okay, now the next problem is where we have to use a special rule. And I should write down some of the special rules that are being used. So for the first two, the rule was that the derivative, d by dx, of a constant equals 0. The next rule was the power rule, which we used for these two examples. D by dx of x to the power of n is equal to n times x to the power of n minus 1. That's the power rule. This is the constant rule. Okay, this one was the constant rule again. Okay, now for log functions. If we take the derivative of ln of x, we get 1 over x. If we take the derivative of ln of w, where w is a function of x, we get w prime divided by w. So here, w is equal to 3x. This thing is equal to ln of w. We take the derivative, we get w prime divided by w. So the derivative of 3x, which is 3, over 3x. The 3's cancel, we just get 1 over x. Shouldn't miss any boxes here. Yeah. Okay, I'm assuming this is not that there's enough students that this is not review for, that we'll cover it from scratch. I'll show you where this comes from. I'll show you where the derivative rules for exponential functions and derivative rules for log functions come from. So that will be something that we'll do. We'll do as if you haven't seen it before, just to be safe. No, I don't want to assume this. I've just had too many students who have no idea how derivatives work for exponentials and logs inside the calc1000 course. That it's not safe to assume you've seen it. Okay, the next one, exponential functions. They have their own derivative laws. Now the difference between an exponential function and a polynomial is in an exponential function, the base is constant, and the exponent contains the variable x. In a polynomial expression, the variable x is in the base and the constant is in the exponent. So 2 to the power of x is different than x to the power of 2. In the function e to the 3x, the base is constant. So there's a few different derivative laws for exponential functions. The first is the nicest one. The derivative of e to the x is e to the x. The second is the derivative of b to the x. For a base that's not e, you get b to the x times the ln of b. And we'll cover this. We'll go through why this happens. And then there's another derivative law for e to the w, where w is a function of x. We get e to the w multiplied by w prime. So I'm going to say this is an e to the w type of function, where w is equal to 3x. So we'll take the derivative f prime of x. I'll use that formula, e to the w times w prime. And I know this is not review for everyone. Don't panic. E to the 3x times the derivative of 3x, and the derivative of 3x is 3. Typically, we put the number in front, so 3e to the 3x would be the way that, if this was a textbook, the way the final answer in the back of the book would be written. All right. Next question is a chain rule. Now, you probably wrote chain rule derivatives with f's and g's in them. And I'm not going to use f or g because sometimes the function is f or g. I'm going to use w again. So if we take the derivative of a function w to the power of n, what we end up with, and this looks a lot like the derivative of x to the power of n, we get an n times w to the power of n minus 1. So just like the power rule, but then we multiply by w prime, the derivative of the inside. So here, w is equal to 5x plus 1. So this expression is w cubed. If we take the derivative, f prime of x, we're going to get 3w squared. So the power comes down, new power gets subtract 1, it gets lowered by 1. Multiply by w prime. We need w prime, we need the derivative of 5x plus 1. We get 5 plus 0, which is 5. And I'm going to plug everything in. W is 5x plus 1, all squared, times 5. And then we can simplify, multiply the 3 and the 5 together, 15 times 5x plus 1 all squared. Okay, next question. This is not a polynomial, this is an exponential function. So exponential derivative rule. D by dx of e to the w. We didn't have this one yet. It's like a combination of two of the exponential derivative rules are in red above. Derivative of b to the power w is b to the w times the ln of b times w prime. So we got 3 pieces will come out. The original function, so this is 3 to the power of w is equal to 5x plus 1. We take the derivative, we'll get 3 to the w times the ln of 3, which is a number, constant, times w prime. I'll plug everything back in. 3 to the 5x plus 1 times the ln of 3 times 5. And there's not much we can do. I wouldn't simplify that. And do you put the 5 in front? Do you put the ln 3? Like, what do you do? Maybe you put 5 ln 3 in brackets and then multiply by 3 to the 5x plus 1. But I mean, there isn't really a standard way to write this. Okay, now we get to j and you're like, oh, thank God. Something normal looking. Take the derivative of 3x squared plus 5x plus 7. Why didn't we start with that? This is just a power rule. And one of the rules that, unsung rule, no name for the derivative of an expression that has a bunch of terms added or subtracted from each other. Take the derivative of each term separately. So 3 times 2x plus 5 times the derivative of x to the power of 1, which is 1, plus the derivative of 7. 7 is a constant, so its derivative is 0. And we can simplify 6x plus 5. And I know that most of you are so comfortable with doing derivatives like this that you would just skip the step where you show the 3 times 2x. You just go right to the 6 times x, and that's okay. You can do that. That's fine. Okay, next problem. Problem K can be solved 2 different ways. One way is to use a quotient rule. I'll do it that way. Well, I think I need more space than that. I'm going to have to write smaller. So the quotient rule says if I take the derivative d by dx, this is a notation that you probably haven't seen in high school. You probably called it f over g. I don't like using f and g in some of my product rules and quotient rules because the function might already be called f. Now you got f meaning two different things in different spots. So the function is never called t or b. So I'm going to call the quotient t over b. T for the top part and b for the bottom part. And the quotient rule, if you use this notation, if you use these characters, will be the bottom function times the derivative of the top minus the top function times the derivative of the bottom divided by the bottom squared. I'll tell you why I like this. Not just because t is top and b is bottom, it's easy to remember that, but also because which one gets subtracted? The bt prime or the tb prime? Well, we subtract things we don't like, and tuberculosis, TB, that TB is the acronym for tuberculosis, and it's definitely something bad, so we definitely want to subtract TB prime. I don't know if there's something good that is b times t. I'm sure there is, I just can't think of it, but I know TB is bad. So anyways, I'm going to use that rule. This is t over b. So using the quotient rule, derivative is going to be bt prime minus tuberculosis prime over b squared. Okay, so t is equal to 5. 5 is a constant. Its derivative is 0. b is equal to 3x plus 7. b prime is equal to 3 plus 0, which is 3. Put it all into the formula. The bottom function, 3x plus 7 times t prime, 0, minus the top function, 5, times b prime, 3, all divided by 3x plus 7 squared. And we can simplify a little bit. 0 times all that stuff up top is 0, minus 15. I would say foiling the bottom is the opposite of simplifying. You're going to make it look bad. Just leave it like this, 15 over 3x plus 7 all squared. So I mentioned that there's two ways we can do this. Here's an alternative. We could say f of x is equal to 5 times 3x plus 7 to the power of negative 1, and then use the chain rule. We're going to get f prime of x is equal to negative 5, the negative 1 comes down, times 3x plus 7 to the power of negative 2, multiplied by the derivative of the inside. From the chain rule, the derivative of the inside is 3. So we get negative 15 times 3x plus 7 to the power of negative 2. And that could be rewritten as negative 15 divided by 3x plus 7 to the positive 2. That's a lot faster. But they're both valid. They're both good. You pick your favorite. I'm going to break the video here and then continue the next problems in another video.